everyone. 3 Carnot engine operates in series between a heat source at a temperature T1 and heat sink at temperature T4. There are 2 reservoirs at temperature T2 and T3 as shown in the figure, with T1 is greater than T2 is greater than T4 and T2 is greater than T3 and T3 is greater than T4. The 3 engines are equally efficient if you have to check out of ABCD which are the correct option. So if you see here, basically you have to find out T2 and T3. If you see here, this is the T2 and here this is T3. T2 and T3. So you have to find out that. So if you see here, you have to calculate the T2 and T3 in terms of T1 and T4, right? So it is given that all the cycle are equally efficient. So I will write down, we know that the efficiency is equals to 1 minus T sink by T source, right? So here if you see here, 1, engine 2, engine 3. For engine 1, if you see, this is the source and then this is the sink. Engine 2, this is the source and this is the sink. So basically I will write down the sink temperature of the 1 by the source temperature of the 1. It will be equals to sink temperature of the engine 2 by the source temperature of the engine 2. It will be equals to sink temperature of the third engine. So this is the sink for the third one, right? If you see here, the finally sink energy will sink. It will be like this. So this will be the sequence. Now if you see here, you can just solve for these two. So I will write down T2 square is equals to T1 T3, and if you see here, if you take these two, then we will write down T3 square is equals to T1 T2 T2 T4. So if you put the value of T2 from this expression, so from here you can just see that the T2 is equals to T1 T3 to the power half. So you can just put the value here. So I will write down, it will be equals to this. So here I will write down, it will be T4. So I put the value of T3 and you can just take this. So from here we can just write down, it is T3 to the power, it will be 2 minus half. So 2 minus half is 3 by 2. It will be equals to T to the power half. So you can just take the power of 2 by 3 and I will write down, it will be half into 2 by 3 and it is this into 2 by 3. So finally I will write down, this is equals to T3 is equals to T1. So if you see here, the power is 1 by 3 and here the power is 2 by 3. So it will be whole power 1 by 3 I will write down. Now we will get the T2 in terms of T1 and T4. So if you see T2 we already wrote here and we will do the same as we do in case of finding out this T3. I will put the value of T3 from here to here and I will write down this T2 is equals to, this is T3. So T3 we already can see it is T2 to the power half and T4 to the power half, right? If you see here, this. So solve for T2. So I will write down this T2 is equals to T1 to the power half, T3 to the power half, and here T3 we already have calculated that it is this. It is T1 to the power 3 and T4 to the power 2 by 3. You can just put the value from here. Right. So I will write down this T3 is equals to, and if you take the power half, it will be 1 by 6, T1 to the power 1 by 6 and T4 to the power 1 by 3. So if you see, this is 3 by 6 plus 1 by 6, it is 4 by 6. So it is T1 to the power 2 by 3, T4 to the power 1 by 3. Now you can just check for the option. So if you see here, this is the value of T3 and this is the value of T2, right? It is T1 square T4 to the power 1 by 3. So B is the correct. Thank you. Hello everyone. A gas can be taken from A to B by two different processes, ACB and ADB. When ACB is used, 60 joule of heat flow into the system and 30 joule of work done by the system, and 10 joule is the work done in case of ADB. Then you have to find out the heat flow into the system in path ADB. So if I talk about A, C, B path, right? So first of all, they both are having initial and final position same, right? For both the process, the initial and final position is same. So the change in internal energy will be the same for the two. That will be equals to F by 2 and R, temperature at point B minus temperature at point A. From the first law of thermodynamics, I will write down the heat given in the first process is equals to the change in internal energy plus work done in the first process, and I said this process as first and this process at second. So I will write down the change in internal energy is equals to Q1 minus W1. Q1 is given is it is 60 joule and work done in the process it is 30 joule. So it will be this. Now, in the second case, if you see, the internal energy change will remain the same. Work done is given it is 10 joule. So I will write down heat given to the system is equals to change in internal energy plus work done by the gas. Work done by the gas is 10, change in internal energy is 30. It is 40 joule, and this is the answer of this question. Now you can check for the option C is the correct one. Thank you.
Hello everyone. 2 moles of an ideal monoatomic gas occupy volume V and then change in internal energy. So if you see, the relation between the temperature and volume of the gas is equals to like this, is constant. So here this is a monoatomic gas. We know that for a monoatomic gas this is 5 by 3. So if I write down the equation, it will be gamma minus 1, you can see 5 by 3 minus 1, it will be 2 by 3. So this will be the equation. Now initially the temperature was 27 degrees Celsius. So I will write T initial is equals to this, that is 300 Kelvin, right? You can write down the equation. It is, if I see 2 by 3 final 2 by 3. We want the final temperature, and it will be equals to 300 into V initial by V final to the power 2 by 3. So V final is 2 times of V initial, right? So V initial by V final, if you see here, it is equals to half. So you can put the value of this as half. So I will write 300 into 2 to the power 2 by 3, and it will be equals to 189 Kelvin. So as you got the temperature, you can simply calculate the change in internal energy, right? So I will write the change in internal energy simply F by 2 nR delta T. Right? So if you see here, it is given that there are 2 moles. So N is equal to 2 and delta T you can calculate, it is 300 and 189 are the temperature. So monoatomic gas 2, N is 2. If you put the value of R, you know it is 8.31. And delta T, I will write this is minus 300. So this 2 will get cancelled out, and I will write 3 into this. If you see, this is 300 minus this, it will be 211 with a negative sign, right? 211 300 minus 189, it will be equals to 211. Now you can multiply it, and after multiplying you will get it is equals to joule. Right? Now if you see, if you convert it into kilojoule, it will be, and this will be the internal energy. Now you can check for the option. So you can see the A option is the correct one. Thank you.
Hello everyone. N moles of an ideal gas undergoes a process A to B as shown in the figure. Maximum temperature of the gas during the process will be. Right, so we have to calculate the maximum temperature. Now you can see the pressure is varying with the volume, right? So if you extend this line, you will get to know the equation of the pressure as a function of V. I can write like this, where m is the slope. So slope is, you can see, negative, and this length is P naught and this length is V naught, right? So I will write minus P naught by V naught as the slope into volume plus constant. So if I talk about the constant, this line will cut y-axis at 3 P naught, right? If you see, there is a symmetry, right? For every V naught, there is a change of P naught in the pressure, right? So if I go leftward V naught, then the pressure will increase by P naught, right? So the constant here is 3 P naught. And this is the function of the pressure. Now we want the maximum temperature, right? So if I write the equation of gas, PV is equals to nRT. So this will be equals to, like, if I put the value of PV and nR, I will get the value of T. So I will write the T is equals to PV by nR. Simple. Now just put the value of PV here. P is equals to minus P naught by V naught into V plus 3 P naught. Simple. Into V by nR. This is the function of the T as a function of V, right? So bringing the constant outside, so you can see P naught is in multiplied it with both. So I will bring the P naught by nR as constant. Now in the bracket I would get minus V square by V naught. This V naught, this V will get multiplied with this term, plus 3V, and is equals to T. Simple. So now just differentiate T with respect to V and make the differentiation 0. Since we know that at maxima the slope is 0, so dV dt by dV will be equals to 0. So minus 2 by V naught. Simple. And plus 3 will be equals to 0. Simple. So you will get the value of V naught here, value of V in terms of V naught here. I will make plus 3 is equals to 0. So I will write 2V by V naught is equals to 3. So from here you will get V is equals to 3 V naught by 2. Now you got the you got the volume at which the temperature will be the maximum. Now you can just put this in this expression, right? So this was the expression of the time temperature, just put the value of volume at which the temperature will be maximum. So after putting the value, you can see if I put the value of V, so P naught by NR, and in bracket if you see minus V square by V naught, so I will write minus 9 by 4 V naught is the V square by V naught, plus if you see 3V, right? So I will write 9 V naught by 2. Simple. So this will get cancelled out. So 9 by 2 minus 9 by 4 will be equals to 9 by 4. So finally you will get the temperature as 9 P naught V naught by 4 NR. So this will be your answer. Now you can see the question again. This was our question, right? And we got this answer. Simple. Thank you.